All right. And so, hi, everybody. My name is Jonas Espanol, CTO of Amberdata. And today we're going to do a deep dive into our API. So before we jump in, just to set context a little bit, we're all familiar with Ethereum. And I think part of the success of Ethereum is because of all the innovation that it has brought to the table. In many different areas, but especially in the decentralization, consensus protocols, resistant to adversity, etc., etc. And I think part of that success is, like a regaining control, redefining Web 3.0, and part of that success is that there's no central party, right? It's all completely decentralized. And part of that is that the whole data, the whole blockchain data is public. Anybody can access it if they want to. However, just because something is transparent or public doesn't mean that it's easy, quick, or cheap to access. And which you think about it makes sense. I mean, the blockchain infrastructure, blockchain data structure was designed for those things like consensus, etc., but not for search or other things that are useful for application development. So as Tong mentioned, at Amberdata, we combined blockchain and market data together, which I think is pretty unique. And so with our API, you get both contexts. You get the blockchain and the pricing or market data together in one API. And what's also very powerful is that you get validated blockchain data. So we'll see in a second what that means. And so today, in this webinar, what we'll talk about is account balances, token balances, and supply. And what we won't talk about is this webinar, but in future webinars, we'll look at exchange and trending data, real-time updates, SDKs, and more to come. So just really quick, where can you get all that information that we're going to talk about? We have a lot of tutorials, we have a lot of documentation. If you have any questions, don't hesitate to contact me either by email, on Twitter, and on my gist in GitHub. A lot of the examples that we're going to look at today are available, so don't hesitate to go there as well. All right, so before we actually deep dive into the API, let's get situated a little bit. So the first thing we'll need is an API key. So this is very easy. Just go to the Amberdata website. Just follow the instructions here. It's very well documented. Sign up. Just enter your name, email, and you'll get an API key. In order to speed things up, so I'm not going to go through that process, but you get the idea. And today, I want to really look at the data itself. So it's going to be very hands-on, very command line oriented. In future webinars, we'll look at how to integrate that into your application, make it a nice UI, etc. But today, I really want to focus on the data itself. And so it's going to be very simple. We're just going to use those 2 or 3 tools here: curl, JQ, and actually we won't use WSCAP today. But so essentially just curl and JQ. And if you're not familiar with JQ, I really recommend you install it and play with it. That's the only thing you will use going forward, I promise you. So how do we get? So let's get configured really quick. So this is just a tiny function that's going to allow us to interact with the API. It's just making a curl, right? Just make it simple to interact with the API. So we can just run it here, grab my key that I retrieved earlier, enter it here, and now I have this function /alias Amberdata that I can use to interact with the API. And so the very first thing we're going to do is look at a few basic commands to get a feel for what the API looks like. So let's look at some blockchain data. So for example, here, the first example, let's get block 0. Okay, so for those who are very familiar with the get or parity kind, you'll recognize information returned by the client. So here we'll see things like hash, block number, difficulty, etc. So everything related to a block. Now we can, so that was the genesis block, right? Block 0. I can just say now get the latest block, so that will retrieve in real time the latest block in the blockchain. Same type of information, right? Nothing extraordinary here. Now, what's kind of interesting is if I specify a block in the future, now I will get an insight into when that block is gonna be added to the blockchain. And right now you see like 4 different estimations based on different moving averages. So kind of it really gives you a range of when that block is going to be confirmed on the blockchain, which it's very nice to display in your application, for example. Then all those. So let's talk about validated data, right? How can you trust that the data that Amberdata returns is correct data? It hasn't been corrupted, or there hasn't been third-party intermediary messing around with the data. So the idea here is that with pretty much all those API endpoints, we have this filter called validation method. And so if I run it, actually it's pretty big, but the idea here is that you will still get all the data of the block that we've seen before, but in addition you get this validation payload, which contains all the data that you need to recompute yourself the Merkle proof, and that's how you can validate that the data is correct. So here, because it's a block, you get all the uncall data, all the transaction information, so you can really recompute all those hashes yourself and verify that the data hasn't been tampered with. So very, very powerful here as well. And just final example here, I can get all the transactions of a block, for example. So again, actually that's a lot. Let me just paginate. So same thing, you get block and then all the all the transaction information. So that block had forget, but like about 100 or so transactions, which you get all the data for in just one API. And it's really cool. All right, so this was just to get, like I said, to get a quick feel for what the API does to interact with it. So now let's dig into a little bit more interesting things. And the first thing we're going to look at is the account balances. And so here, think about it, right? If you had to, given a wallet address, if you had to retrieve the account balance for that wallet address, okay, I mean, that's by itself, that's pretty straightforward. I can just ask my Ethereum client, get a parity or whatever other client, hey, balance of my wallet address, and it's going to return the current account balance. But now let's say that I'm interested in looking at the history of my account balance, right? Like think about a bank account, right? You want to have the history of all the transactions and the total amount over time. So same thing, right? You can make the same call, specify a block number, but it starts to get difficult pretty quickly, right? First of all, you're going to have to make that call, more than 8 million times now, since there's more than 8 million blocks on the blockchain. And then for that, you're going to need a full archive node, not just a full node, a full archive node, right? Which at this time requires about 3 terabytes of disk space just to hold all those state. again, right, all that thing can be computed, all that thing, there's nothing magic about it, anybody can do it, but it starts to be a little bit cumbersome, costly, etc., right? So instead, Amberdata has already indexed all that data for you. So, I was going to say at the click of a button, you can retrieve all that data. So let's take a look at how to do that. So first thing is we can pick a specific wallet. I like to use this one for demos because it's a pretty big wallet with a lot of ether, a lot of movements, and a lot of tokens. So it's very nice for demos. So let's define our wallet address, and then let's take a look. So the endpoint here would be address, wallet, the wallet in question, account balances, and historical, because we want to look at the historical account balances. So if I run this, all right, so this is going to give us the whole history of that wallet, and the format is so the way that the data is returned is as an array. So it's very easy and fast to parse, and you get, so in this case, the address, which is the address of our wallet, block number, meaning which block the account balance changed, because even though there's more than 8 million blocks, the account balance didn't change at every block, right? So we only return blocks, timestamps when the account balance changed. And then what was the value, what was the actual balance. Now, what becomes more interesting is to add this filter, include price equals true. So the idea here, if we run it, is that, remember, Amberdata combines blockchain data and pricing data. And as part of our processes, pipeline, etc., we ingest all the historical Ether price, for example, as well, all historical token prices. But so what's interesting here is that now, with that filter, there's an additional column return, which is the price. So you see, at this block number, that account balance was equivalent to that many dollars. At this other previous block, the balance was equivalent to that much dollar value. And again, right, we're not using just the latest Ether price. This is based on the price of Ether when that block was created, at the time that block was created, right? So it's using all the historical Ether prices. And now, finally, just to show you, how quickly it is to use, I can just use JQ here. I'm not going to go into details, but JQ JSON querying to parse and format that data into a CSV. So there you go, right? I just really quickly converted that to a CSV, and I can just grab, oops, excuse me. I can just grab all that data, put it into an Excel spreadsheet. No, I already did it earlier, so let me delete. There we go. Paste it back. And again, very quickly, I can take a look at the history for that wallet. And we can see that it's a very big wallet. And it's been oscillating between 13 and 14 million, right? So it's big swings happening in that wallet, which is very interesting. But again, right, the idea is here in just one API call, I can look at any wallet historical account balances. So, think about, your own application. Again, it's very easy to add that type of information, chart it, et cetera, and provide a lot of useful information to your users. So let's continue. So that was account balances. Now, the next thing is token balances. So this, becomes a little bit even more difficult than account balances. Again, think about it, right? Here's a question, right? Given the wallet address, your wallet or any other wallet address, you wanna know which tokens they hold and what was the history of their holding over time. Simple question, again, the analogy with the bank account, right? If you have assets in your trading account or whatnot, that's the type of information that you expect to see, right? Well, if you think about it, token transfers, right, is what makes it's what changes your balance, your token balance for specific token. Token transfers, they are not part of the blockchain data, right? They are, you can get access to them as part of the debug traces or internal messages, depending how you call it. But even then, so you can look at the events or the logs, right? Most ERC20 tokens out there emit the transfer event, for example, right? So you could look at that. But even that is not completely accurate because some contracts don't emit that event, or again, right? You would have to think about it. You would have to replay all the transactions from the beginning of time, which is a huge amount, right? You would have to replay all of that over time, filter by the address that you're interested in, the address of your wallet, and look for transfer events, extract the information from it, etc., etc. So again, it's not anybody can do it. That data is public; everybody can access it, but it was not meant for that type of search. And so we've done all that heavy lifting here. So now it's very easy to access. So let's take a quick look. So the first thing is that call here, address tokens. And right now I'm just limiting it to the top 20, but you can get more if you want. So the idea here is retrieve the top 20 tokens by value that this wallet holds. So we can just go here, run it, and we can look. So there we go. This wallet that we've been using as demo purposes here is holding many different tokens, but the top 20 by values are those here. Here is the address for each token, and the current value. Now, again, quick manipulation. So I'm sorry. So now I have the top 20 token. Now I want to know the history of all those token holdings. So for that, I can use this other endpoint, holders historical. I'm going to give it the holder address, which is my wallet. And the API is a little bit limited. Actually, no, sorry. I'm just interested in the last 30 days here. So I'm just essentially looping over all the tokens, retrieving the historical balances for each of them, and putting it all into a CSV. So second API call here. You can see each call for each of those top 20 tokens. Now, if I look at the generated CSV file, we can see each token and then all the different changes in holdings over time. And so finally, again, to make it just more visual very quickly, some quick ad hoc magic to pivot it so it's more usable. There's no API call here, but so now all the data has been pivoted, so it's ordered by time and then by tokens on top. And why I do that is because now we can plot that right here. So I've done that already. And now, again, very quickly, in just a few API calls, I can have a complete history of the token holdings, essentially the token portfolio for that specific address. And so, for example, we can see that it's very much a holding wallet, right? They buy and they hold forever. Recently they've increased their holdings for some tokens. And again, it's one of those demo wallets, but the whole combined value, remember, right? Blockchain data, market data, blockchain data, pricing data. So I've thought of those API calls, we return the price of those tokens in dollars, etc. So we get a combined value for token holdings for that wallet, you know, in the vicinity of 20 billion here. By the way, you know, I'm not making this up, right? This is a real wallet. You know, you guys can go check it out. You know, it's on chain. All right, and then to finish, I wanted to talk about circulating and total supply. So the idea here is to look at the supply for a specific token, and there's many different ways out there to define supply. We are going to focus on two. So one is total supply. So this is the supply as advertised by the contract itself. So as part of the ERC20 specification, you have to implement this total supply function. And so, you know, that's what total supply is. And so again, because we're interested in historical views here, we've indexed, we've collected and indexed the total supply for every token over time, and so which we'll take a look at in a second. And circulating supply. So like I mentioned earlier, circulating supply, there's many different types of definition out there. But because at Amberdata we're very focused on validated data, meaning data that other people can verify and calculate themselves as well. So our definition of circulating supply is the sum of all token holdings in all wallets out there. So essentially, it's looking at every wallet on Ethereum, looking at how many tokens, how many of that specific token they're holding, and you know, most of the time, circulating supply and total supply is going to be the same or very close to each other. But in some instances, because the contract has been hacked, for example, you know, we've seen this before, where suddenly the circulating supply is much higher than the total supply, which means that some people were able to generate tokens without it being tracked correctly by the contract, or you know, things like that, right? Especially for tokens that, for contracts that burn or mint tokens out there, that's pretty common. So anyway, again, you know, same idea here. You know, we've done all the heavy lifting already on this circulating and total supply, and so we can take a look at it. So in this case, now I'm interested in this specific token. So I'm going to define that token here. In this specific case, I know that that token started to be in circulation around July 2017. So I'm just restricting my time range to 2017 to today. Oops. And excuse me. And then I'm using the supplies historical endpoint, and because this could be, you know, a lot of data, the API doesn't allow you to retrieve more than, I forget, maybe 30 days at once. So this loop here is just to loop in 30 days chunk to aggregate the data in CSV. So you know, it's the same API call, just called with different time ranges. So right here, you can see each call for each of those time ranges. And we look at supplies, yes, supplies. Right. So here, what we see, you know, again, in one API call, right, you get the history of circulating and total supply, as well as the number of holders of that token at the time. And so again, you know, we can plot that CSV very quickly, and it looks like this. So for that specific token, I think it was the BNB token. For that specific token, we can see that, you know, around February 2018, the number of holders increased tremendously. So that's probably when they made it public or something like that. And the circulating and the total supply. So first of all, as you can see, they don't exactly match each other, which depends on the burn and mint event and how the contract keeps track of the tokens in circulation. And then at some point, the supply tremendously went down. I think that's around the time they decided to burn a bunch of the Ethereum token to move to their own blockchain. So we're getting close to the end of the time here. So again, just to summarize, right? What did we see here? So with the API here, the whole idea again is that we've done all the heavy lifting for you, so you don't have to do it because it can be very costly, very inefficient to access. So you get real-time access to very difficult to access blockchain data. In this webinar, we looked at the historical account balances, token balances, and you have very powerful APIs because again, with one API call, you get validated data, so you can actually prove to yourself that the data is correct, that it hasn't been tampered with, and you get at the same time, price information. Very, very easy to add very powerful data and information into your own applications. And that's the end. And we'll do many more seminars and webinars to look into other aspects, like I mentioned before, like real-time data, WebSockets, all of our SDKs, etc., etc. Thank you very much.
Thank you, Jonas, for your time today. And for everyone on the call, now is the time. If you have any question, feel free to reach out. We don't get to have Jonas in person very often. And so there's a couple ways to do it. You can either raise your hand and I will allow you to talk through the Zoom, or you can type your question in the Q&A. Click the Q&A button and type your question there, and we can address them accordingly. While everyone's asking questions, just like Jonas mentioned, over the next couple weeks, we're going to host a series of webinars and demonstrate other capabilities of our API. In today's session, it's more or less an introductory session. If you enjoy today's content, please make sure to follow us on Twitter, sign up for email, go to amberdata.io, and we'll notify you when the next session will be hosted. With that said, is there any questions? Any hand raised? All right, I see one question.
Hi, I have a question about the API introduced today. It's like, can you guys get the detailed transactions of each token? Like, if I want to get a Tether token on Ethereum, can you guys get the detailed transactions in one day, like from which address to another address, and how much is it?
Yeah, it's all part of the API. Just looking for the actual endpoint here. So, if you go to our docs, we've separated into different namespaces essentially. So you have the market data, which we haven't really talked about today. Okay. Have all the blockchain data, and so if you have a token, for example, then you can use the forget which one, but yeah, so you can use one of those endpoints here, for example, to get all the transactions. Each endpoint has a lot of filters. So if you don't specify anything, you will get all the transactions. But then we have filters where you can get all the logs, you can get all the token transfers, etc., etc. So it's you can get a lot with just a few endpoints. Okay. And if you have something that is not in the API, please let us know. I'm sure we have the data. We just need to expose it to you.
Oh, okay. And then how many like how many data can you get for one time, like for the transactions?
Yeah, so it depends on your subscription. So the developer subscription, by default, I think it's the maximum pagination is set to 100, but you can paginate yourself, right? You can say get page 1, then make another call to get page 2, etc. And you have access to all the data. It's just limited per call. And if you're in the professional subscription, I think it's set to 1,000.
Okay. What about the transaction? Like the time frame is like in minutes or seconds or hour or a day?
I don't remember. I think it's it depends on the endpoints, right? So most blockchain data related endpoints don't really have a time frame. It's more.
Jonas, I believe maybe he's asking about rate limits. And if I may add, for the developer free tier, the rate limits, it's 3 calls per second. And for the professional tier, it's 15 calls per second.
Right.
Yeah, that's all for me. Yeah.
Okay, great.
Thank you for the question.
Yeah,
anyone else have a question? All right, that concludes today's webinar. Thank you, Jonas, and thank you everyone for joining today's session. Follow us on Twitter and we'll announce our next webinar. Thank you all. Have a good night.
Thank you very much. And if you have questions, please don't hesitate. We're here to answer all of them. Thank you. Bye.